All right, last lesson of the unit. This one might be a longer one, so stick with it and then you'll be done. So we're going to talk about inequalities first and what it means to be a solution to an inequality. So we're just going to give just a basic single linear inequality. Let's say y is greater than or equal to negative 2x plus 9. And so the way I can test to see if a point is a solution is by plugging in the x and the y and seeing if it's actually true. So let's test it out. Let's plug in 4 greater than or equal to negative 2 times 7 plus 9. This would be 4 greater than or equal to negative 14 plus 9. And 4 greater than or equal to negative 5. Is 4 either bigger than or equal to negative 5? Yes, it is. It's greater than. Let's try B. 3 greater than or equal to negative 2 times negative 1 plus 9. That would be 3 greater than or equal to 2 plus 9. 3 greater than or equal to 11. Is that true? No. So negative 1, 3 is not a solution. And C, negative 5 greater than or equal to negative 2 times 10 plus 9 is negative 5 greater than or equal to negative 20 plus 9. Negative 5 greater than or equal to negative 11. Is that true? Yes. Negative 5 is bigger than negative 11. So that's how we see if a point is a solution to an inequality. We're going to get into systems of inequality. So we have two inequalities and we're looking for their solutions. And the specific inequality symbol tells us two things. When we're graphing these inequalities, we have to shade in part of the picture because it's not just what's on the line. It's everything either taller, bigger than, or less than what's, where that line is. So the specific inequality symbol tells us where we shade and what type of line it is. So if it's a less than symbol, either less than or equal to, it's going to be below. We're going to shade below the line. So both of these are below. However, the line that we draw is different. If it does not have the equal to part, it's just a dashed line. When you draw the line, when you're graphing the line, you just make it dashed. And then if it does have the equal to, it's a normal solid line. Now the greater thans, those you both shade above. Greater than is above. And again, if it does not have the equal to part, it's a dashed line. If it does have the equal to part, it's a solid line. So when we're graphing, we're going to have two different lines that we graph, and we're going to shade with both of those. So we're going to do them separately. Then the solution is where they overlap. So if you have like two different colored colored pencils or pens or something that you could use, now would be a good time to get those. So we're going to graph. Let's look at the first one. And I want to make a note of those two things, the where I shade and the type of line. So in the first one, it's a less than symbol. So I'm going to be shading below, and I'm going to use a dashed line. So let's do that one. Let's graph it. So put my y-intercept on -3. We're going to graph this line just like normal. And my slope is -4/3. I can't go down 4, so I'm going to go up 4, left 3. And it's a dashed line, so I'm going to draw a dashed line the best that I can. And it says to shade below. So I am going to color, and now if you're just using a pencil or something, I would not completely color it in. I would just do like little marks like that. But it's easy for me to color in on my iPad, so that's what I'm going to do. Okay. I know it's not perfect for you OCD people. All right. So that's the first line. Let's move on to the second line. That's this one. This one is greater than, so we're shading above, and it's just going to be dashed. So I've got my 3, and my slope is 2/3. And I'm going to be shading above. You don't want to do this really dark. You know, you want to make it light if you're shading. Every time that we do these systems of inequalities, there's going to be 4 sections. Oops. This is a section here, this big one's a section, this is a section, and this is a section. There's always going to be 4 sections. And one of those 4 sections will be your solution. It's the one where your colors overlap. In this case, it's the little one. So what I want you to do is I want you to make it obvious where the solution is by putting like an S for solution in the section that it is. So the section that was double shaded, that you colored in twice, or that you made marks in twice. You may have just done little squigglies like this. That would have been fine. But whichever one you did with both colors. All right, let's do number 2. So number 2, let's start out, has a y-intercept of -2. Oh, and I didn't go back and explain. The solution on these is not the point where they cross, because these are inequalities. It's that entire shaded region. The entire double shaded region is your solution. So you're not going to have just a single point as your answer. All right. So I graphed my y-intercept of -2 and my slope of 1. This one is going to be a solid line. Because I have the equal to part. And it's less than, so I'm going to be shading below. The next line has a y-intercept of 1 and a slope of -2. it is going to be a dashed line because it doesn't have the equal to part, and I'm shading above. A lot of people struggle with the shading part. When you're shading, a tip that you can use, a lot of people think I'm shading left or right. No, you're shading above. So the steeper the line is, the harder it is to see that. So what you can do is if you put your pencil or your colored pencil or whatever on the line, if we're shading above, go up, up. Not left or right, I'm drawing up. And this kind of gives you a hint at where you should be shading. Shading over here. It looks like it's the right, but it's not always right or left. It's either up or down. That's where the shading is. And my solution is where they overlap. So make sure you mark that really good with an S. You will get points marked off if you do a solid line versus a dashed line. You have to look at all of those parts. Everything like that is important. I want you to try number 3. So pause the video and try number 3. All right, number 3, we had -1 with a slope of 1. You should have drawn a solid line and shaded above. The next line, we had our y-intercept of 3. This one was a -1 slope, and this one is dashed. And again, we shade above. The part where they overlap is the solution. Number 4. See if you can do this one on your own. Starting out, I had a y-intercept of 3 and a slope of 1/2. It's a dashed line. And I'm shading below. Next one, -2 and a slope of -2. This one is a solid line. And I'm shading below. This is a steeper one, so it's not as obvious where below is, so draw lines going down, not left, not right. And my solution is where they overlap, which is where I'm drawing this S. I'll pick 2 more to do. We'll do the last 2. Number 7. You notice these have the same slope, so they're parallel. That does not necessarily mean they have no solution. It could mean they have no solution, but depending on the direction of the shading. So let's graph these. We have -1 and a slope of -1, and it's a dashed line. And we're shading below. The next line has a y-intercept of 3 and a slope of -1. Now, if this one was shading above, then this one would be no solution because there would be no place where they crossed. However, it also says to shade below. So there is a place where they cross. And then number 8, the first line is easy. -2 and a slope of 5/2. Oops, this one's dashed. Easy to miss it. So I would not recommend using a pen for this. This one is shading below. So I'm going to take my highlighter and go below the line. It's not left or right, it's below. And then the other one is y is greater than 3. So this is just a horizontal line that goes through 3. And it's greater than, so we shade above. And so my solution is this little spot here. If you got a little confused, I would go back in the video to where I very first started explaining because I was slower and I explained more steps. So if you got confused, go back to example 1 and re-watch that one. And if you have any questions, feel free to ask me. Have a good day.